Okay, 6 o'clock. Let's get started. So tonight our topic was section 20, division circuit. Let's get started. So tonight our topic was, oh, okay, that was it. All right. So any question on this specific topic or anything else? While I'm checking the discussion page, if there is any other question there.
Yeah, Professor, I was kind of confused with the simplified process for this division, similar to how I was confused on Monday with the multiplication. Can you do an example like that again?
Simplified division.
Yeah, kind of the process behind it and exactly what's going on with the simplifications there.
Right. So instead of example, did you watch those other like associated videos regarding the explanation?
Yeah, I did, but I kind of, it was tough to follow along there.
Okay, let me see. Let me pull up that first, and let me see if we can go from there. Okay, so we are talking about that one which uses the 32-bit register, 32-bit ALU. Okay, all right. So let's see. Digital. Okay. So I'm talking about. Let me share my screen. Yeah, I'm talking about the video which was describing with this digital perspective too. That is more like that explanation itself. Let me see. So this one is telling you that. Okay, let me. So our we start with the divisor as a constant, right? And also we put the quotient onto the our sorry, dividend into the quotient register. So that is the first part of it. Okay. So we start with the dividend in the quotient. So this is my dividend. This is my dividend. And then divisor is a fixed register for us, and there is this remainder register, separate one. So the philosophy here is that we are trying to bring in the dividend aligned with the divisor. Okay, so let me okay let me pick one example on the paper pencil to do the concept. Give me a minute, but before that let me just go through this one first. Okay, then I will tell you uh, one example on the paper and how it equivalent to. I'll try to manage that, but let's first go with this one. Okay, clear all drawings. Now we first do a right shift of the quotient register, quotient from the towards the remainder. So means this your MSB will be going over to the remainder register, and so it becomes like this, right? And a 0 is introduced in the quotient register. And next thing we do a subtraction between remainder and divisor register and put that in the remainder. And if the remainder is a negative, then we roll back and finalize my LSB. Means so far, this is grayed out, means it is not finalized in this picture. It is not finalized. It is just a prospective result that quotient bit may be at this position 0. We start with that. But here, since the remainder is negative, we can finalize this bit. Okay. So now there's a next step. We finalize and then again shift. Okay. So we do that repeatedly. The same process. We shift left, bit comes into the remainder register, and subtract, check if it is a negative. If it is negative, roll back and finalize the LSB. We do the same thing over and over again till we get something like, let's see. So at this iteration 6, we do, yeah, now we subtract. And now you see this, your result. Your result in the remainder is a positive number now, right? In the positive number now. So in that case, what we do need to do is replace this 0 with 1. So that's why how we can achieve that in a hardware. It is we cannot just go and replace and load a 1 bit there. We need to have a mechanism. So that's why we first right shift so that this guy gets thrown out, and then insert 1 onto that position with a left shift. So you're at the end of the day, your remainder register content will become same, but as if we replace this guy with 1. So that's what happens here. And then we go forward, shift, and then do another subtraction, which is positive, insert one more 1 here. Iteration 7, we did a similar thing. We have a positive remainder, so do fix it as a 1 there. Okay, and then we are done at that point, right? So how it works out with respect to the other process. Okay, with respect to the other process. So let's look at that. So let's take the same example. Let's take the same example and let's see. I have, sorry, my is crashed. Just give me a minute. My application got crashed. Okay. So we have two numbers. One is dividend is 0, 0, 1, 1, 0, 1, 0, 1. Okay. And my divisor is 0, 0, 0, 0, 0, 1, 1, 1. Okay. So this is my dividend. Oops. So this is my dividend. And this is my divisor. Now, in a normal case, what would we have done is this. Like we introduce double bits, right? And then we make a subtraction process. We make a subtraction process out of this one, right? And then check, of course, this is a higher number, this is a bigger value, then, and this is a smaller value. So my result would become somewhat negative. So that means in that case, what we would have done is to roll back the result and insert a quotient bit as 0, right? That's what it is. So in that process, we are constructing the quotient as a separate bits. Okay, it starts with 0, all 0, 1, 2, 3, 4, 5, 6, 7, one more, 8. Okay, so this is my quotient. This is my quotient. And what shall we do here in this case, in this first step, with negative like subtraction here, right? We get a negative value. We get a negative value. And as a result, what we'll be doing, we'll basically insert 0. Let me change the color here. Okay. Insert a 0 in this position. Okay. And as if we are finalizing 0 over here, right? And then we roll back. Then we roll back to the previous value under the divisor register with a addition operation, which will give back this one, right? And then what we do, we basically shift this bit pattern. We shift this bit pattern. So that means what I'm talking about, we basically shift this guy. So a new 0 would come here. And we'll throw out 1 0 from here. Okay, and then, yeah. Now we repeat the same process. Now again, this value is somewhat, is bigger than this value, right? So we are, let me bring down these two levels also. So we repeat the same process here. We introduce another 0 from the left side. Like we insert this guy over here. So let me just do that for that process. We insert 0 here, 0 here, and we roll back. We roll back. And then we do the similar operation again and again and again till I get something like, let me see. Hey, I didn't change this bit pattern. What was my divisor? Divisor was 0, 0, 0, 0, 4, 5, 1, 1, 1. So until we shift this whole thing about here, where we get the first iteration or step where our subtraction operation becomes positive. Okay, our subtraction operation becomes positive. And at that point, definitely we are going to change this whole thing, extra zeros over here. One more maybe, yeah, and this 0 would be reduced to 2 of them. And at that point, this subtraction result is stored here, whatever that subtraction result is, and which is positive. And in that case, at that point, we will insert a 1 here into this point, right? Now you see the whole point is we are kind of shifting this. Let's forget about all these things, but let's talk about the dividend and divisor bit pattern. And we are basically shifting this bit pattern towards the right side and trying to align it with a position where my subtraction result become positive, till my subtraction result become positive. Instead of doing that, what we are trying to do with the simplification process is we are shifting the dividend into the other part. Okay, so basically, instead of doing that, let's say this is my quotient register, which is loaded with the dividend pattern, and this is my remainder register. So in that case, what is happening in each step, we basically shift in this bit pattern onto that register. Okay, and how we do that? We basically pick the MSB in the hardware, insert it into the LSB by shifting this guy. Okay, shifting this guy. And as a result, we introduce a quotient by default 0 over here. So let's do that. Okay, how can we do that here? Okay. Step 1, 0. So what happens, this 0, let me color code it. Okay, this 0 goes over here. So can I color code partially? No, okay, Control Z. So first shift operation, what is happening is basically we pick up this 0, and as a result we are introducing a 0 over at the right hand side LSB position, and this 0 is shifted out. Okay, and the 0 from the dividend bit pattern comes here. Okay, and then we do the subtraction between divisor and remainder, right? And if that subtraction result is a negative result, we finalize this bit itself. Okay, now let's say at some point of time, okay, so we are basically shifting, and what's that? 1, 2, 3, 4, 5. I think after some point of time, maybe after 5th, 1, 2, 3, maybe at this point, let's understand this snapshot over here. So what we'll be shifting here is something like this. One more. Okay, at some point of time, it becomes like this. And this one may be, okay, 2, 4, 6. Okay, 2 more bit I need to left. And we are all finalizing with zeros. Okay, so 2.
Would it not have checked on the 5th rotation and found a non-negative?
5th rotation?
Yes.
Yeah. I'm just giving a snapshot example. I'm not really doing this. There will be too much to do that. I'm just trying to explain the concept, what's going on here, right? So 2, 4, 6, 7. So far we have this one, and this one is not finalized yet. And now we see we have a positive subtraction result. My subtraction value would be positive. So at that point, what we'll do, we'll throw this out. We'll be shifting all these parts, right? So this guy will be shifted over here, like one of this bit, like one more bit, and then we introduce 1. Insert 1 over here. So that's the rollback and adjustment point, basically. Okay, so that's what is happening in this whole process. So is that kind of making sense now? Or if you have any other, if you have questions, please let me know.
Yeah, that made some more sense. Thank you.
Yeah, please review that video with the animation that I have shown you on the digital perspective 2 and 1, and try to compare the process. Okay. Okay. So how is the project going on?
Pretty good.
It's coming up. Yep. All are writing reports now.
Starting on them.
Starting on it. All right, that's good to know. We have our deadline is 30, right? November 30, is it?
Yeah.
Yeah. So you have some. Yeah, just don't ruin your Thanksgiving with this project, okay? I hope not. So yeah, I hope everybody is done with implementation, maybe testing right now. I started with the report. Parallel report writing would be a good one. All right. What else? Any other questions? Let me see if you guys have. Okay, let's do this thing. Pop quiz. Go to your canvas, find out pop quiz number 7, and tell me when you are ready to enter the quiz password. I'm launching the poll. Once everyone is ready, I will give the password. Let's see, 33, 35 of 37, 2 more people. Maybe a couple of more seconds. The 2 more people need to confirm. Okay, so let me now give the password. Here it go. I think most of you, the time is up there. Let me check. Yeah, I think it is. So if we get back to the quiz, 747, we start. Let me share the quiz stat with you quickly. So you see the high score 77% with average score 44%. Yeah, I believe division circuit, that today's topic was not that good from you guys. Please make sure you check out that and understand the topic. Anyway, I don't have anything else to do tonight. If there is no other question, we can stop here. I will publish the grades or the answer, basically. Answer key through the pop quiz now. And if you have any question and see discrepancies, just let me over email, okay?
Thank you, Professor. Good night.
Thank you, Professor.
All right.
Thank you,
Good night.
Professor.
Thank you.